How are you, Balam? If your network is good, you can please unmute and let us know.
I'm fine, sir. I'm good.
Okay. So how is your studies going on? Is it going on okay?
It's just okay only.
Okay. So if you have any doubt, okay, feel free to contact us. Okay, maybe through WhatsApp or like that if your internet etc. is less. Okay. So
Okay, yes, sir.
okay. So up to the last class, anyone having any doubt? Ask maybe Balam if you have any doubt, we can clarify those doubts. So I have already shared one this one assignment with you people. So Balam also it is already there in the Google Classroom. So you whenever your network is good, you download it. Okay, and the last date I think is given as 16th of November I think. Okay, so it will be after Diwali and all. So go through it, and it is up to the assignment topics. It is up to the last this one. Okay, last module whatever we have already discussed. So in the last class, we have completed the HARF module, that is high energy rate forming processes. So there are already different types of HARF processes we have discussed. So we have also discussed what is this HARF, why the transition has happened from traditional manufacturing process, that is the forming type traditional forming processes, to what are the reasons to like the transition to HARF. Okay, so why people are shifting sometimes to HARF. Okay, so the all those different possibilities which are not otherwise possible, so those kind of possibilities we can get in this HARF forming processes. Okay, and later on we have seen the how the high strain rate or the high energy rate that will be required for undergoing all those hard processes, how different ways we can produce them. Okay, and depending on the nature of production of this particular high energy rate, how we have discussed about the different forming hard processes like explosive forming, electromechanical forming, electrohydraulic forming, etc., etc. And we have also discussed their capabilities, advantage, disadvantage, and some specific application of all those electromagnetic forming process for expansion kind of process, expanding, then for swaging process, then the different die configuration or coil configuration we have discussed. Okay, and later on we have also discussed about when the conductivity is less in case of our uh, close like flat die. Okay, flat coil configuration in electromagnetic forming. So what are the special requirement, etc., or special arrangement that we do? Okay, so those things already we have discussed, and we have completed the third module. So if you have any doubt, you can ask, or otherwise you let me know that you have understood the thing, and we'll move ahead with the fourth module, which is about thread and gear manufacturing process. So here in this particular process, in this particular module, we are going to discuss about, basically there will be two parts. First part will be, we'll be discussing about the different processes by which we can manufacture screw threads, and next in the next part we'll be discussing mostly about the gear manufacturing method as well as gear finishing processes. Okay, so if you have any question you can ask, or otherwise you people can let me know to go ahead, and we'll move ahead with this particular module. Any question that you want to ask me, any clarification that you need? Okay, so I hope there is no confusion and all. Okay, so now we'll be starting about this particular module, trade and gear manufacturing process. So now, prior to going through the different processes or what is this thing, so let's discuss your views first. What do you understand by this particular trade or gear? Okay, why the manufacturing process, the understanding of this manufacturing process? Why do you think it's important? What is your view? Anyone? Or why it is used? What is the, definitely it has to have some use, right? All those trade, etc. Okay, or gear. So I think about gears all of you already know. So now, what about trades? Why we are specifically discussing about trade manufacturing? Why is this important? Why do you think? What do you think? Or what are the different? What is your views about this? Have you undergone any process by which you can generate or manufacture trades? I believe in your workshop you have done that. Anyone would like to share his view, his or her views? You can unmute and you can let us know. Seems like no one. Okay, so then we'll discuss. Okay, so now this thread, actually we'll be mostly talking about the screw threads. So why these are very important? Okay, I believe about gear all of you already know. That means the in the kinematics and theory of machine also we have discussed about different gears and all, how they operate, what is the use, etc. So basically in, so those are kind of like for transmission of motion, power, etc. And in various machineries to move different parts and all, so proper engagement of gear it will be required. As gear, this is a very important mechanical element, so ultimately discussion of or the knowledge of the manufacturing processes of gear, that will be definitely important. So now what about these threads? So now why we are talking specifically about thread is because, see, if you look at your surrounding different mechanical elements, if you look, okay, in somewhere or the other, okay, of maybe different size, shape, etc., you'll find some element which has got thread in it, okay, be it kind of screw or the nut, all those different, okay, fasteners and all. So basically that screw threads, okay, this is very important. These are very screw threads are, and as well as gears, they are very important machine elements, okay. So in most of the machines, if you look at, so it will have some definitely some gear arrangement so as to give the movement and all to different links, pairs, etc., okay, and to work with different mechanisms and all, okay. These gears will be there, okay, some motive for some transmission of motion, etc. It will be happening there in the machines and all. And these gears, they are one of the very vital element in any machineries. And apart from similarly, like these screw threads, the threaded elements, these are also very important. So you'll go through, you'll come across various threaded elements there. Maybe if you have seen maybe the um, lathe machine, you have operated in the lathe machine, they are also one of the very vital element that you have seen is, that you have discussed, was the lead screw. So now that lead screw, which is very vital in case of all those like this lathe machine and all, okay, that is also is nothing but it has got some thread on it. Similarly, the different screw, okay, the nut hole that you see there also, you'll see some thread, it is there. Similarly, maybe if you look at the, okay, the bottles, okay, from which maybe water bottle that you from where you drink the water and all, so there also you have seen the caps which are there, okay. And if you look closely, so basically it has got thread in it, okay. So these screw threads and gears, okay, in our day-to-day life we are always using it, okay, somehow or the other. If you look at you maybe the wristwatch, that the analog one that maybe some most of you are using, or maybe the wall clock and all, ultimately there is some gears, etc., that is involved. And to fasten it, you have seen maybe different fasteners that we use. So one of them is like using the screw, etc., okay. You can do different this kind of okay. Now this, as we are saying, that this screw threads and it's a very important, so you'll be fascinated to know that the more screw threads are made each year than any other machine element, okay. The screw threads, okay, their size it varies from very small, which are used in maybe your the watches that you have seen, okay. So similarly, like we have got different shafts, threaded shaft, maybe which is diameter is like 10 inch, 12 inch, or like that, okay. So heavy that kind of bigger like thread also we have, threaded part also we have. And similarly, if you look at the very intrinsic, the minute threads, threaded part that we see in the watches, okay, small watches, rich watches and all, okay, those are also there also we see the different threads. And this particular, if we're talking about this particular thread, okay, their precision it varies from the normal hardware screws which don't have that much like precision, okay, like but and to the kind of the lead screws of that that is there in the very precise machine tools, okay. Using that lead screws, we already know precise movement we give to the different machine beds and all, okay. And you can think about the precision level which we use in, which you get in terms of the different threaded elements. So like the inexpensive hardware screw, okay, which is not, we are not bothered about that much precision and all, we are just fastening it with the help of suppose the screws and all, okay. That kind of purpose suppose we are using. Apart from that, the lead screw, if you can think of, we talk about very precise movement and all, okay. So that is basically about like the different introduction. Now these traits, okay, just like if you see about, if you have discussed about, you already know about the gears and all, you know about internal meshing, external meshing, you know about internal gears and all. So in the similar context, so here also in case of traits, it may be we may have trait on the like external trait which will be cut on the external periphery of the supposed workpiece, and we can also have the internal traits which are generally like you can I think all of you can understand internal and external, the meaning of internal and external. So the thread also we can produce on the internal surface, that will be known as the internal threads, and on the external surface of an element, if the thread is being cut, those becomes the external threads. And there are a variety of methods, okay, and variety of words that we use, like threading, thread cutting, the thread rolling, etc., etc. So all of them, they basically refer to the manufacturing of threads, mostly on the external surface or the external diameter. And there is one method known as a tapping. So basically, with the help of this word tapping, we basically refer to the machining, refer to machining of threads in the already drilled hole. So now in like for uh, or mostly to manufacture threads on the internal surface for cutting internal threads and all. In general, the normal thing is already we'll be having some drill holes on, from which we get the starting surface. Okay, so like this. And once again, like as we are doing the introduction, so this is basically about your thread. Okay, and now about gear, we already know the very importance of gear. What kind of like from very small this particular gear which you see in the rituals to the different gears in maybe different ships and all. There are very huge like gears are there, okay, to propel them, and so that kind of thing is there. And it will be safe to say, like even though we say that wheel, it is one of the very like it's the invention which has changed the human civilization, but we can even think that like nowadays even it's kind of more important than even like you can say like the wheels also. Okay, why? Because to like to give the motive power to the wheel, we require some, like we generally apply the torque and all with the help of some gear arrangement. So you can think of like why this is very important. Okay, so that's basically about the introduction. So I hope all of you have understood why the understanding of this is required, gear manufacturing as well as trade manufacturing. This or no? Let me know your view. Okay. Okay, so now some of the very general application of the different screw throughs, okay, screw threads that we'll be discussing. So, what are the different application areas of screw thread? So, the screw threads, okay, these are, this can be used in fastening, okay. So, just like the screws that you see, the nut bolts, the studs, which are having screw threads, okay, and generally they are kind of temporary fixing, okay, temporary fastening kind of thing. You can they are not permanent type of join, okay, temporary kind of thing, okay. You can uh, join them, or if required you can like separate the elements also. Similarly, like in joining purpose, we can use like coaxial joining of rods, tube, etc., by different external as well as internal screw threads which are there and at the ends, okay. And similarly for clamping purposes also, so as to strongly hold the object by the threaded rod, like you have seen different tails, like the different C clamps you have seen, bends, vice, etc. You have seen there also you have got threaded elements, screw threads. Similarly, to give very controlled linear movement, like that of the traveling of the different slides which are there in the tailstock barrel, the compound slide that you see, cross slide, etc., that you have seen come across in the workshop, okay, and maybe the uh, different CNC machine tools and all, which gives a very precise movement or control area movement. So in those areas also we see different screw threads which are there, threaded elements are there. Similarly, by the help of the lead screw, which you have seen in the maybe in the lathe, which is very evident. Okay, so there we do what we do, transmission of motion and power. So there also, if this kind of threaded elements or screw threads they are using. Similarly, conversion of rotary motion to translation motion, position controlling in different instruments. Okay, like in the microscopes, in the precision movement of work table in the microscopes and all. Okay, so as to do proper positioning in the instrument, we have all the screw threads. Similarly, precision measurement of length, just like in the case of threaded spindle in the micrometers and all. Okay, And we also if you have seen the worm and wormhole, there the worm, it has got some screw threads, okay, threads cut on it, so it can also act as the worm. Like similarly, for exerting heavy force in the help of suppose mechanical presses and all, there also you will come across different screw threads and so on. Okay, the list continues. So these are a variety of different general applications of screw threads where you'll see some threaded elements, it is there. Okay, now, like we'll be coming to the thread making process. Now, there are basically three basic methods which are mostly used to produce the threads. They are cutting methods, okay, next the rolling method, and the casting method. So now, in the cutting method, you can very easily say that it's a kind of subtracting kind of method. That means the profile of the thread, be it external or internal kind of thread, you are going to cut the thread profile on the workpiece, and thus you are going to manufacture or the produce thread. So that particular category will come under thread cutting. Next, we also have thread rolling process. So where you'll see that as we have already discussed about rolling, so one of the possibilities there itself we have discussed, we can go for rolling of thread by the help of different thread rolling operation. So that there in that particular case, if we go for this particular operation, then that will become a thread rolling operation, and it's kind of a forming operation, that is thread forming kind of thing. Similarly, by casting method also it's possible to generate thread. So for that you already have to have the mold where you'll be having the thread on the like that mold will be having that particular shape and all. Okay, and that if you can heal up, then mostly the external threads, or sometimes if you use a proper core, so internal threads also can be cast. But this casting, the threads which are made by casting, it is generally of short length. That means we don't go for that many threads in a by casting procedure, and the precision, okay, or the precision that is obtained, okay, is generally low in casting thread, cast thread. Okay, so these are some of the three main methods by which we can produce screw thread. Now, even though we are saying that we can cast external as well as internal thread, but it's, as I have already discussed, relatively very few are made in this particular meter, because with the help of die casting, in connection with die casting or investment casting or like that. Okay, so as I have discussed, so generally precision etc. This kind of less, and this cast thread sometimes you can even see in the bottles. Okay, maybe like the glass bottles also you have seen that. So the accuracy level of that particular traits, okay, it's not that high. And as we are saying that these are all those possible methods like cutting, rolling, casting, etc. Out of the casting, it's not so common for thread making, but it's possible, and in some of the cases it is done. And but thread rolling is one of the very, you can say, the largest number of threads are being made by rolling process. And here by rolling process, we can manufacture both external as well as internal threads. But as you have seen in the case of other rolling operation, so as to be able to produce proper threads on this particular workpiece, okay, the work material has to be ductile. Okay, we should be able to compress that particular like you already know how in the rolling process basically we can give the shape. Okay, so it will be kind of shape rolling. And generally, as we are talking of this rolling process, and this rolling is kind of is less flexible process than kind of your cutting process, straight cutting process. So it's generally restricted to standardized and simple parts. And still, as we are saying, that is generally this is the restriction that is there. So because of that, still a very large number of external and internal threads which are still made by different cutting processes, and it also includes like grinding, tapping, etc. Okay, so here in this particular list I have enlisted some of the possible methods to generate or to cut external thread. Okay, and similarly these are cutting method only, and some methods to cut internal threads. Okay, so now for external thread cutting methods, so we can cut the threads by using the normal lathe, okay, engine lathe. And similar is the way by the help of using ANSI lathe, you can cut thread. And I believe this thread cutting on lathe machine you have already done as a task in your workshop. So you already know how we actually cut the thread in lathe machine. Okay, so different attachment it is there. Similarly, by manually by doing by using the different dies, okay, so that can be also done. And similarly, with the help of automatic die, which can be used in turret lathe or screw machine or in the different C lathe, it this external threads can be cut. Apart from that, we can also even go for milling methods by which we can cut thread on the external surface, as well as even possibilities are there by grinding, even specialized grinding. We are able to get the profile of the thread which are on the external surface. Similarly, for internal thread cutting, we can have threading by engine lathe or engine lathe. Okay, the threading process. Okay, so it's possible to get that particular internal thread cut. Okay, for that specialized, the tool will be there. So tool will be different. So as you already know, for doing special operation, we have different types of tools in that is used in the lathe machine. Similarly, with the help of tape and the holder, okay, we can go for cutting internal thread and different collapsible tapes we have which can be used in turret lathe and all. And even by milling process, it's possible to get internal threads. So actually, by the help of this milling process, it sometimes even becomes easy to get the internal threads. But the thing is, for getting the internal threads, which will be there in the internal surface of a workpiece, so we have to have that particular hole first. So that is one of the basic requirement. And after that, on that particular surface which is already being generated by drilling process mostly, so we manufacture the threads on it. Okay, up to this much I believe it's okay to everyone. Just let me know someone, have you understood or not? Yes, you have understood, right? Okay, thank you. So now, in this subsequent slides, what we'll see, we'll be going through different possible methods of production of screw threads, and we'll look at their characteristics. So first, we'll be talking about this casting method by which we are going to produce screw threads. Right now, everything we are talking of this screw threads and production of screw thread, and we'll be discussing about the characteristics. And so, whenever we are talking about uh, these screw threads which are being manufactured by casting method, general case is, in general, only a few threads over a short length it is being done by, it is generally made by this particular type of process. Okay, last part. Why? Because of this particular it is generally less accurate. Okay, and accuracy level is somewhat less and poor finish we have. So what is the meaning of only having only a few threads over short length? So we are talking about, that means suppose this one, suppose this is the element, then don't mind my drawing. Okay, so if you are generating threads like this, okay, so we are talking only having only 2 or 3 turns over the length. Okay, that length is kind of short length. Okay, so maybe this particular length we're talking about. Okay, short length and having less number of turns. Okay, only less number of teeth over the thread. So that is generally that kind of thing is generally done in the like by casting method. Why? Because that generally the surface finish that we obtain in the in case of casting and all. Okay, it's very less and accuracy level also is less. As and this kind of cast screw thread you can see at the mouth of the different glass bottles. Okay, span cast iron pipes, etc. So it is very. I think most of you have seen the cut in the glass bottles. You might have seen. Maybe the you might have come across in the normal glass bottles for your milk. Sometimes it is there. Okay, one or only one or two thread. That means only suppose the whatever you call generally as the cap, which has got the subsequent thread. Okay, that thread is metal match there. Okay, male and female part. So in there you can see suppose only one or one turn or half turn. That kind of locking and unlocking, that kind of thing is there. Okay, very small thread, one or two turns is there. Similarly, maybe you might have seen in the mm that ghee bottles, the ghee bottles which are made of glass, maybe the Annapurna ghee or so, whatever you generally see in your household. There you might have come seen that the these bottles, okay, these bottles the after one or two run, okay, after one or once we have opened the mouth, open that particular cap, and you have close it once again, open and close. So the accuracy is not maintained. Okay, so those kind of thing, and that while either opening or closing that particular cap, okay, basically you have seen, just if you just rotate it by suppose uh, half of a revolution or within a one revolution, single revolution, it opens. Okay, so that means the number of thread that is there, that it is very few threads are there. Okay, understood. Similarly, we can have a forming process, that is we have already talked about, that's the rule forming process. So like in that particular case, what are the characteristics? So in the case of rolling process, okay, thread rolling, the different blanks of different strong but ductile metals like steel, etc., are rolled between threaded dies. So what we have to have, so in that particular case, as we already know, this is a kind of forming process only. Okay, so sorry. So in that case, what will happen? You'll have that particular, uh, suppose to it, flat rolling is also possible, and another type of rolling also is possible, which will be circular kind of rolling. So both are possible. But suppose I am talking about the flat rolling. So in that particular case, suppose this particular workpiece, it will be here in that particular case, and on this particular surface as well as in this particular surface, actually you will have the thread cut required profile of the screw thread. Okay, and when you'll be rolling them, okay, by using that particular proper compressive force and all, it will be compressed, and on this particular workpiece, actually externally you are going to get the thread. Okay, so actually in this particular surface and in this particular surface, which is going to, which will be rolling, as well as the, it will be compressive force will be there. So on that two surface periphery, actually we'll have the teeth profile. Okay, and large threads are generally hot roll, which are generally followed by finishing, and smaller threads are directly cold roll, so as to get the desired finish. Okay, why large threads are generally hot roll? Because while we go for hot forming and all, so the ductility of the metal is generally get increased, and the strength generally is kind of decreased, so as to, and the process becomes easier. And as like any kind of your cold forming process, so cold rolling, it gives you more strength and toughness to the threaded parts, and generally it is widely used for mass production of fastener like bolts, screws, etc. Okay, that is basically what the characteristic of regular thread forming process. Similarly, we can have different machining process, that is removal process, and what are their characteristics? Now, in that particular case, removal process, they are accomplished by various cutting tools in different machines. So we can go for lathe machine, okay, we can go for milling machine, drilling machine, even like in the drill, by drilling also that is possible. We can use the appropriate tapping attachment to it, and even by the help of using drilling machine, okay, radial drill generally. So we can make the different internal threads also and these are all removal process, that is the machining process. And for getting very high accuracy and high finish, generally it is widely used, this kind of machining process are generally widely used. And it also varies from like even for high value volume of production, okay, or maybe sometimes even single piece also we can manufacture. That means the volume of production, it is a diversified range, it is possible by this kind of removal processes. Okay, so similarly we can have some semi finishing to finishing method. Okay, so under that the grinding will come. So it's generally what happens by this grinding process, even though we are saying we are producing screw threads and all, and mostly it is usually done for finishing purpose, so as to get the proper and accurate surface. And generally after performing certain machining or different rolling operation, and it's generally is done. And if we're talking of making sometimes the threads in rods, okay, is sometimes this grinding process can be directly applied. Okay, and a variety of range of type and size of threads is possible. The volume also is kind of high volume. A variety of volume also is possible. Similarly, we can go for different precision forming to near net shape forming processes. Okay, already we have discussed about what we understand by net shape manufacturing or near net shape manufacturing. So basically, what happens in this net shape manufacturing or near net shape manufacturing? So in general, in a single go, we get the end result. So no machining will be required in that particular net shape manufacturing process. And sometimes a very little grinding it might be required so as to get the very high level of accuracy and finish. And application, so it's kind of the investment costing for job order or batch production. It's a kind of you can go for, let's say, production by injection molding for different polymers already we have discussed. Okay, so it's maybe for batch production, maybe for mass production, that's possible. And similarly, we can go for different non-conventional manufacturing process. You might have already come across all those EDM, ECM, electro-discharge machining, electrochemical machining, etc. So by them also, by the specialized non-conventional machining processes also, it's possible to cut thread. Okay, so mostly we sometimes employ wire EDM and all, and it can be employed. And when we have to go for these non-conventional processes, so these non-conventional processes sometimes you might have to go for when the conventional method fails, maybe even in the micro domain and all, or maybe when the uh, material you cannot process by other means and all. Okay, so then you might have to go for this kind of non-conventional processes. And like the accuracy and precision that you can obtain by these particular non-conventional processes. Okay, so here it is kind of very high. Also micro threads we can get generate. Okay, you can go for like wire EDM, and other methods are also there. Okay, micro EDM it's there, so it's possible to get that. Okay, so in the micro to nano level you can even get the pins. Okay, similarly which the materials which are very difficult to process by conventional means, you can go for this kind of non-conventional process for manufacturing. Okay, so with this we'll stop here for today, and if you have any question you can ask me, or if you have understood you can let me know. So thank you everyone for joining. Just you can have any question you can ask, or if you have understood you can let me know. Okay, hope all of you have understood. So thank you everyone. We'll stop here today. We'll meet in the next class. Thank you. I'm stopping the recording now.